Hey Carmody Cougars, this is Miss Casperson. Today for our math intervention lesson, we are going to go back and we are going to revisit how we factor numbers. So factoring, what that word means is it means we are going to find all the numbers that multiply together to get our target number, whatever our target number is. So for example, if I was working on this first problem right here, I'm finding the factor pairs of 24. 24 is my target number. How I might start thinking about that and doing it is I'm going to say, okay, well, I know 1 is a factor of every single number because 1 times our target number, or 24, will get me to 24. So both the numbers 1 and 24 are factors of 24. These two numbers together, 1 and 24, are what we call a factor pair because together they multiply to get to 24. Another factor pair of 24 is 2 and 12 because 2 times 12 gets me to 24. So again, I know that both the numbers 2 and 12 are factors of 24. We're going to continue to work on this today and think about how we can find all of the possible factors of our different target numbers. And then at the end of the lesson, you're going to be using this to solve some different puzzles that you're going to need to know your factors in order to solve. All right, so let's go ahead and get started. Let me just erase this. All right, so we're going to continue with this number 24. 24, we already decided we know every single number has 1 as a factor because 1 times the target number 24 is going to get me to 24. So I know 1 and 24, and I'm going to use this number line to help me, are both factors of 24. I also know that all possible factors of 24 must be smaller than 24 in order to multiply by another number and get to that target number. So I know all the rest of my factors must be between 1 and 24, and that's why sometimes using a number line like this is really helpful. The next factor of 24 I might consider is I might just move up and go from 1 to 2, and I need to think, can I multiply 2 by something to get to 24? And I know that answer, because 24 is even, is yes. So I know 2 is another factor of 24. Now I need to think what I could multiply 2 by to get to 24. And I know that that other number is 12. So my next factor pair is 2 and 12. Because I now have 2 and 12 as a factor pair, and because there is nothing between 1 and 2 that's a whole number that I can multiply something else by to get to 24, I know that all of these bigger numbers here, between 12 and 24, none of them are factors. Again, this is why that number line is helpful, because I can visualize seeing all the numbers that are no longer possible. Okay, I know 2 and 12 are factors, and now I'm going to change my color, and let's think about the next possible factor pair. So I might just go right up to the number line to the next option, and my next one I'm going to choose is 3. So let's consider the number 3. I would think to myself, is there anything I can multiply 3 by to get to 24? And I could even count up by 3s, and I know eventually I will get to 24. So 3 is a factor of 24, and to get to 24, I would need to multiply by 8. So 8's my next one. Again, now this allows me to cross out 9, 10, and 11 because there's nothing between 2 and 3 that could factor pair up with those. Okay, next I'm going to go to the number 4. For the number 4, again, I'm going to think, is there anything I can multiply 4 by to get to 24? And the answer again is yes. The answer is 6. So 6 and 4 are another factor pair of 24 because 4 times 6 is 24. That crosses out 7. I can't do anything with 7. Now I come to the center number, 5. I need to think, is there anything I can multiply 5 by and get to 24? You can count up by 5s and you would see, nope, there's nothing I can do, so 5 doesn't work. What I have here is a table of all of the possible factors of 24. This is it. There's 8 of them. All right, let's try this again. We're going to do it again, but this time we're going to have a different target number. So if I go to the next slide, my target number is now 18. If you notice, my number line on the bottom has shifted between the numbers for the numbers only 1 to 18 because, remember, factors must be smaller or they can be equal to our target number, but they cannot be bigger because we have to only multiply, okay? All right, so I always start out with 1. 1 is always a factor. Every single number has a factor of 1. And I know that to multiply 1 and get to 18, I would need to multiply by 18, the target number itself. So my first factor pair is 1 and 18. All right, I'm going to work my way up the number line. Now I'm going to go to the number 2. Here for 2, sorry, I'm changing my color. Here we go. Here for 2, I need to think, is there anything I can multiply 2 by and get to 18? Again, because this is an even number, I know 2 is going to work, and I know I would need to multiply by 9. So I'm going to put 9. And again, there's no numbers between 1 and 2, so none of these numbers between 9 and 18 can work either. That's what's helpful about these number lines. Then we're going to go to the next one. Let's think about the number 3. You think, is there anything I could multiply 3 by and get to 18? And again, the answer is going to be yes. If you need to, you can always use the side of your paper or use your fingers and do some counting up and see, do I ever, when I count up by 3s, get to 18? I do, so I know it must be a factor. And I know I must multiply by 1, 2, 3, 4, 5, 6. So 3 and 6 are my next factor pair. Now I'm going to think about 4. I just think, is there anything I can multiply 4 by to get to 18 this time? All right, well, if I think about the number 4, I know I go 4, 8, 12, 16, 20. Nope, I cross over 18, so 4 does not work. Now I need to consider 5. Can 5 work? I could count up by 5s, 5, 10, 15, 20, and I skip 18 again, so 5 also doesn't work. So 18 only has 6 factors, or 3 factor pairs.
Hey Cougars, Miss Swack here. Now that you've gone over how to find all of the factors or factor pairs with Miss Casperson, we're going to talk about how we can apply those factors. And we're going to use something that we call factor puzzles. You'll notice we have here listed all of the factors that you just found for the numbers 24 and 18. And one thing that you might start to notice is that different target numbers can share or have the same factors in common. So for example, they both have 1 as one of their factors. That means 1 is a common factor for 24 and 18. They both also have 2 as a common factor. 3 is a common factor. Okay. 4, while it's in the factors listed for 24, there isn't a 4 in the factors for 18. So 4 is not a common factor. Same for 18. 18 is only in 18, not in 24. 9, only in 18, not in 24. But 6 is common for both of our target numbers. These common factors you can then use to think about these target numbers in a slightly different way. What we're going to do is we're going to introduce you to something that are called factor puzzles. And what factor puzzles are is they look like this. They look like kind of a 4x4 window with some lines out to the side. What these numbers are is the numbers inside of our box are what are our target numbers. Okay, those are our products. Those are the ones where you're multiplying 2 numbers together to get that. The lines off to the side are always going to be where your factors go. And so in order to think about this, we're going to have to look at all of these target numbers and think about what factors do 2 of them have in common. So for instance, I'm going to start with this very first column. Okay, my products that are inside my little window there are 24 and 18. I have to think about what numbers, what factors do 24 and 18 have in common? Which factors would occur in both lists? Well, if you remember from what we just talked about, they actually had several that occurred in both lists. In order to think about that, we have to understand sort of which one we need to do. Our goal with these factor puzzles is to figure out this number that's missing. And in order to figure that out, I have to know what this number is and what this number is. In order to help me figure that out, I have to know what all of the other factors are. So I'm going to start with a common factor of 24 and 18. I know 24 and 18 share a factor of 6. Well, if 6 is a factor of 4, that must also mean that 6 is a factor of 18. Now, if 6 were not a factor of 18, I'd have to choose a factor that I know both of them have in common. But I know that 6 works for both of them. You'll notice I wrote 6 both on the top and on the bottom. Every time you list factors, it's opposite end. So like top, opposite end is bottom, left, opposite end is right, are going to be exactly the same. So now that I know 6 is a common factor of 24 and 18, I can start breaking it down and look at individual numbers. If I know 6 times something equals 24, I need to figure out what that something is. Well, that's where those factor pairs come in. Okay, I know that 6 times 4 is 24. And because those opposite sides have the same factor, I also know that 4 is this factor over here, even though I don't know what number it's multiplying to be yet. Okay, now I'm going to go down to 18. 6 is a factor of 18. So to figure out this one, I have to figure out 6 times what equals 18. Okay, 6 times 3 is 18. Again, opposite side is also going to be 3. 3 times something equals 12. Yes, that's true. 3 times 4 equals 12. And since opposite ends are the same, I end up with a 4 there. That tells me that to find this one empty box, I need to take the 2 factors I've circled and multiply them, just like I did with all of my other ones. So I'm looking at 4 times 4 is 16. So the number that fits in that space is 16. That's the solution to this puzzle. Now, some of you might be saying, wait, more than just 6 is a common factor for 24 and 18. And you are absolutely correct. So let's look at what some of those are. Okay, if I chose something other than 6, for instance, I know that 3 is a common factor of both of them. Now I'm going to start the process again. 3 times what equals 24? Well, 3 times 8 equals 24. I move 8 to the other side because those opposite ends are always equal. Now I'm going to move to the bottom. 3 times what equals 18? Well, 3 times 6 equals 18. Move my 6 to the other side because they're equal. 6 times what equals 12? Well, 6 times 2 equals 12. Move that up to the top. I now have 8 times 2, which again we already know is 16. So it doesn't necessarily matter which factors I choose, as long as the factor I choose is a common factor for both of my target numbers. Okay. I could even choose a different number other than just 6 or 3. Like, for instance, I know 2 goes into 24 and 18. Okay, let's start this process again. 2 times 12 is 24. Okay, 2 times 9 is 18. Here's where I can't use just every factor that they have in common. and where I really have to do some deep thinking to make sure that all of my factors fit. Because if 2 times 8 or 2 times 9 is 18, if I move the 9 to the other side, I have to ask myself 9 times what is 12? Well, if I skip count by 9s, 9, 18, I skip over 12. 9 is not a factor of 12. So I can't use 9 there. But since 2 times 9 is 18, that also tells me I can't use 2. So when you're thinking of the factors for these factor puzzles to figure out this final number, whatever common factors I choose also have to work not only vertically in these columns, but that means that their pair, the other one that goes with them, has to work horizontally with those rows. And that's where some of that deeper thinking goes. We're going to let you guys try your hand at a little bit of guided work. We've given you a new factor pair. You'll notice it has new products in the middle. You're going to have to think about, number one, what common factors do these numbers have in common, so that I can find the number that's missing that's for that yellow box. Let's start out. Let's start with 15 and 35. If I start with 15 and 35, I have to think about what are the common factors. What is a number that I can multiply and get both 15 and 35? If I think about my factors for 15 and 35, I figure out pretty quickly that 5 is a factor of both. If 5 is a factor of 15, 5 times what gives me 15? What number should go here? Right, 5 times 3 is 15. Now I have to look at my other one. 5 times something equals 35. What number needs to go there as my pair to go with 5 to equal 35? Right, 5 times 7 is 35. Here's where I need to do a quick check. 5 times 7 is 35, but is 7 a factor of 49? Can I multiply a number by 49 or by 7 to get 49? Yes, I can. 7 times 7 equal 49. Now that I've filled in all of my factors, I can simply multiply these two factors together to get my target number that's missing. 3 times 7 is 21. Great job. You guys are now going to go on and practice some of these factor puzzles in your connections class. Should you have questions, feel free to re-watch parts of this video to learn how to do factor puzzles. You can also ask your connections teacher, as they are all experts in finding factors as well.